In this video, we're going to model and pattern a six-sided sail. We can see here this is a wave-shaped sail, starting with a low connection, low, high, low, high. When we look at this in front view, you can see the traditional high-low configuration, and in plan view this is a symmetrically shaped structure that is 6 meters in this direction and 12 meters in this direction. Now that could be 6 feet and 12 feet. This is unitless in CAD. We can see the ground here and then the individual posts that represent the connection point. For MPanel though, all we're interested in is these 6 connection points and a polyline that represents the tops of the poles. In this example, we're going to use a sail that uses a single cable around the outside and round clamp plates. And we're going to use clamp plates that are similar to this style with some sort of tensioning device. This could be a toggle bolt or a shackle and a turnbuckle. And we can see we've got 4 bolts and a connection point to the clamp plate. We need to know the distance from the center of the clamp plate to the actual tensioning hole. In MPanel we will work to the center of this clamp plate. To explore this in more detail, go to top view and we'll look at a typical example of a clamp plate here, which is 150 millimeters or 6 inches in diameter, and the distance from the center of the clamp plate to the tensioning hole is 40 millimeters. If we wanted a tensioning device length between the post and the clamp plate connection of say 300 millimeters or 12 inches, we need to take into account the fact that MPanel works to the center of the clamp plate, not this point here. So we need to make an adjustment in the length to account for the distance between here and here. This will obviously vary for different clamp plate designs and will need to be accounted for in your design. In this example, we're going to use 260 millimeters as a distance from the connection point, the post, to the tensioning point of the clamp plate, and we're going to add on the additional 40 millimeters to the center of the clamp plate. So we're going to use a link length in MPanel of a total of 300 millimeters, 260 plus 40. So we'll go to perspective view, and we're going to use the model builder tool and draw a hyper. I'm going to right click on this tool. Because the width of the structure is twice the distance of the height, we'll increase the MSurf to twice the NSurf, and we're going to select a corner link, simulate round end. The link length we stipulated was 300 millimeters or 12 inches, and we know the width of the clamp plate to be 150 millimeters or 6 inches. Click OK, and in this case we're just going to add a 4-sided mesh because the sail is symmetrical. We'll select the bottom left, follow the instructions, bottom right, and top left. Now it's important to note when we use the hyper tool, MPanel will also add a 3D polyline to the mesh. So we need to delete this because we already have a 3D polyline here. We can now see we've got links in every corner, and if we look at the detail of one of these links, we'll see that it's 300 millimeters long. But if we use the MPanel extended data tool to get data on this, we can actually see that it is original length 300, that it is a simulating a round end and a width of 150 millimeters. Now, this is useful because if, for example, we wanted to make the link lengths different in each corner, then we would simply select them and use the extended data to make changes to suit each individual corner. So we'll go back to top view, make a copy of this. We're going to make a copy of this link, this special link for the corner, and we'll add it to the midpoint here and here. Turn on the control points for the mesh. Select the middle control point and connect it to the end, and the same here. Middle control point and connect to the end. Turn off control points. Now we're going to relax this as a cable edge mesh. We'll look at the options. We're going to use a cable tension ratio of 7%, and that suggests a cable tension ratio of 1.82. 1.82, and because this is a single cable, we're going to select the option same tension on all edges. This is critical whenever we're using a single cable because we have a single tension by definition. Click apply and select everything and relax as a cable edge mesh. We can see we had a zero residual error, and we can zoom in here and see at least 4 zeros after the decimal point, which is what we're looking for accuracy in residuals, and then delete old. Now, what's critical here is the link is pointing in the right direction for the force balance shape. Delete old, and there's our mesh. Now let's just look at the length of this corner link. We'll look at the details in Rhino. There are several tools you can use to look at the lengths, but we can see here it's 147.97 millimeters. Call it 148 millimeters. This link length, on the other hand, is 220. So these link lengths have actually been adjusted automatically by MPanel so that the fabric will be sufficiently wide. The 150 millimeters we specified as the width of the clamp plate at exactly 300 millimeters away from the center of the clamp plate and the corner connection point. Let's just look at this. I'll copy this over here. We're going to split the mesh into 4 panels. Paneling normally, so vertically. Click OK and run the tool. Delete old, and there are the panels. Now we'll zoom to the sample I made earlier. We can see the clamp plate we discussed earlier located in the corner of the sail. Here is a circle of 300 millimeters. If we look in detail at this, this is the radius of 300, and that is from the center of the clamp plate, and here we can see the link that we specified, which is exactly 260 millimeters. Another important tool, we can take a copy of the model. We can accurately determine the exact cable length for the project by selecting everything and run the tool, and we can see the area of the model. We can see the individual cable lengths on each edge, but we can also see in the information area the total cable length is 36,316 millimeters, but the corrected cable length is 35,887. To explain this, the total cable length would be the length from point to point all the way around the outside, and if we added up each of these individual edge lengths, they would sum to this value, total cable length of 36,316. However, we know the cable does not come to a point. In fact, the cable hits the tangent of the clamp plate, then goes around the pulley edge and then back down the other side. And this portion of the cable is deducted, and this is the corrected cable length. Thank you for watching. For more information, please contact support@mpanel.com.